Hi everyone. Today we will do some advanced problem in the topic of indices. They are not very advanced in the sense that we do not want to do something that's not for standard 9 and 10. We currently want to do some difficult problems of the level of standard 9 and 10. We do not want to get into equations of indices etc. at this point. So I think some of these examples will be helpful. So we've covered the basic laws, we've covered the fractional negative indices, we've covered scientific notations. We want to do this topic. This will help us close the chapter. Okay. Like always, if you have any questions, please feel free to put them through in your comments, and then we'll try and answer them as quickly as possible. Okay. So some examples of indices that you may see in your exams. Okay, so let's take some complex ones. 125 to the power minus 2 by 3 times 625 to the power 3 by 4. Okay, as I said earlier, as soon as we see these numbers, something should strike us. What was that? Remember? 125. If you start factorizing 125, what do you get? This is 5 cubed, right? So 5 cubed, and this is similarly, you should be able to write this as 5 to the power 4. Now, as soon as you've written this, this becomes very straightforward. You multiply them, this becomes 5 to the power minus 2, and this becomes 5 to the power 3. And using the basic indices addition rule, you just add them, 5 to the power 1. 5 is the answer. It didn't look like 5 when we started, right? And the reason is that all of these numbers are created in a manner that you should be able to factorize them and simplify them at this stage. Okay, so don't get flustered when you have complex expressions. It is just a way that we've learned we should be able to simplify. So numbers like this should give us some indication of where we're going. And that is why it is important for us to maybe memorize some powers of basic numbers like 2, 3, 4, 5, 7, 6, etc. Okay, let's take one more that might look complex. Remember, they are not. 8x to the power 3 by 4. And then that is squared minus 2. You have to divide that by half of x to the power minus 1 and this whole thing to the power 2. Looks pretty complex. How do we deal with it? For things like this, 8, what does it tell me? Immediately as soon as I see 8 in the chapter of indices, the first thing that it should tell me is this is 2 cubed. And this is x to the power 3 by 4. Minus 2, that's okay. Divide. I know this may not be useful in this example, but this is very useful to know. Okay, and in this case, this is half, it remains as half. X to the power minus 1 is 1 by x to the power 1. So what, we haven't solved this yet, but we have simplified this a bit. Now I can use this power and multiply it with each of these. So 2 to the power 3 by 2. Then x to the power, see this is 3 by 4 and minus 2. Multiply them, gets you minus 3 by 2. Okay. Now see, this is divide. So I can write this below. 1 by 2 square times 1 by x squared. Okay. The numerator, I'm not changing this for now. So I keep 2 to the power 3 by 2. This is 2 to the power 3 by 2 remains as it is. And this is x to the power minus 3 by 2. Sorry, I made a mistake here. This is minus 6. This is 2 to the power 3 into minus 2 is minus 6. Okay, let's take this separately. Let's do it again. I made a mistake there. 8x to the power 3 by 4, and this is minus 2, divided by half x to the power minus 1, and this goes squared. So 2 cube and x to the power 3 by 4 minus 2 divided by 1 by 2 times 1 by x squared. Okay, 2 to the power 3 and minus 2. This 2 gets multiplied. Remember, this is bracket outside, so these are all powers. So 2 to the power minus 6, and this is x to the power. These 2 gets multiplied, 2 gets cancelled, minus 3 by 2. Okay, similarly when we expand it here, we get 1 by 2 squared and 1 by x squared. Okay, we are writing this as 2 to the power minus 6 into x to the power minus 3 by 2 divided by, this is divide, remember, 1 by 2 squared and 1 by x squared. This can also be written as 2 to the power minus 6 times x to the power minus 3 by 2. This is divided by 2 to the power minus 2. Remember, when you want to do a reciprocal of a number, you take a negative sign. Sometimes taking a negative sign is more useful. And this is x to the power minus 2. Same process. Okay, so I'm just following it up here. Now, these two are similar quantities. So 2 to the power minus 6 plus 2. Because it is divided. Remember, when you have anything divided, you do subtract. So minus of minus 2 is plus 2. Similarly, x to the power minus 3 by 2 plus 2. So this is 2 to the power minus 4 into x to the power plus half. So this is 1 by 16, and this is square root of x. The answer should be x root 16. Okay. We'll take some more. Examples. So one problem I have from the book is this: 3x cube y squared by 6x square y square divided by 5xy squared and 27x9 y9 and 1/3. Okay, so this is the problem coming from the book. Australian Curriculum, Unit 2, Level 1, indices, chapter 2, level 2 indices. Okay, now let's just keep going, right, and we'll get somewhere. See, we should know what are these things going to give us, but let's keep going. So this is 3 cube times x cube times y square. Let's bring all of, so there are 3 different quantities. There are numbers, there are x and there is y. So we'll bring all of them together. Right? So this is 6 squared, x squared squared is x4 and y squared squared is y4. Okay. Now you know that if we have a by b divided by c by d, we can write this as a by b multiplied by d by c, right? When you multiply, you reciprocate the second part. So we can do this. So we can write 27 x9 y9 to the power 1/3, and this is 5 squared is 25, or you can write it as 5 squared, and x squared y squared. Okay, so we'll keep going. 3 cube x cube y cube, can't do much about them, can we? Okay, yeah, we can. So 3 cube remains 3 cube. This is x cube minus 4. I have taken x4, I have taken that there. Y square minus 4. And this number is actually 3 squared times 2 squared. So 6 is 3 times 2, right? So if you take a bracket and write 3 times 2 and then do a square of that, this is what you get. In this one, this is 3 cube x9 y9 1/3, 5 squared x squared y squared. So this becomes 3 to the power 3 minus 2. This is 3 and the same base and 2, so I am subtracting this. This becomes x to the power minus 1, and then you can take this x squared, which is in the denominator, minus 2 there. Y, this is minus 2 and then another minus 2 from there. Right? We're left with this 2 square here, which is 4, and a 5 square here, which is 25. Okay, so in this one, what I can do here essentially is I can do a 3 times x cube and y cubes whole cube, and this 1/3 remains here. See, what I have done essentially is just taken the common powers out. All of these had a power of 3, 9 and 9, so all of these were multiples of 3. So I've taken the cube power out and I'm left with this. This is still the same formula, this one. So if we have distributed this here, in this case we've just extracted it out, and you can see the reason why. I can now cancel these two powers. 3 times 1/3 is 1, so I'll be left with just that. So 3 to the power 1 times x to the power minus 3 here, y to the power minus 4 times, this is just 3 to the power x cube and y cube now by 100. Okay, now 3 and 3 times 3, 9, x to the power minus 3 and plus 3, so x to the power 0, this is 9 by 100. From a numbers perspective, x to the power minus 3 and plus 3, so x to the power 0, and then y to the power minus 3, minus 4 plus 3 is minus 1. So this is 1, so 9 by 100 times 1 times 1 by y is equal. So the answer is 9 by 100y. So this may look complex at the initial part of the question, but as you start going through this and start completing that, it will come through. Still keep going is the process, right? Keep simplifying the way you can. If there are multiplication or division, just try to bring all of them into multiplicative form and then try to solve them using this same process, and you will see you will be able to apply some of these rules and remove some of these fractional powers, and all of this will go, and then it will simplify into some of these basic identities of indices, and then you will have your answer pretty. So the answer is 9 by 100y. Let's take one example of a simplified notation again from the book. Okay, I'm taking 1.9 times 10 to the power minus 3 into 2.4 times 10 to the power 4 divided by 8 into 10 to the power 4. Okay, so 1.9. So let's bring all the similar quantities together and all the dissimilar quantities together. They are all multiplied, so you can separate them the way you want. Okay, these gets cancelled out. Now if you want to do the multiplication of this, we can write this as 1.9 into 24 by 10, and this is 8 here, right? What I have done is 1.9, I have done 24 by 10 because I know these things get cancelled out, and then this is 10 to the power minus 3. You don't miss anything. This gets cancelled. 3, 1.9 times 3, and then we have 10 to the power minus 3, and then 10 to the power 1. So this becomes 5.7, and this becomes 10 to the power. This is 1. It goes up. It becomes minus 1. So that's your answer in scientific notation. Okay, we'll do a few more sums before we finish this chapter. Feel free to ask any questions that you may have, or send out your comments as needed. Now this is also from the book, so we will see if this helps. See, these numbers should strike something. I've said this before, anything like this, it should strike something. This is 3 to the power 4, and this is 2x plus 3 divided by, this is 3 to the power 5 and x minus 1. Once you've written this in this form, this becomes very, very simple. 3 to the power, this you have to multiply them, 8x plus 12 divided by 3 to the power 5x minus 5. Okay, now because you are dividing and you have the same base, so you can use 3 into 8x plus 12 minus this entire thing has to be subtracted. See, you have to be careful with these signage. You just can't do a minus 5x minus 5. You have to do a bracket because this entire quantity and these two entire quantities are the powers, so they have to be subtracted together. 8x minus 5x is 3x, and 12 plus 5 is 17. That's your answer. This is the simplest form. of the answer you can have. We can take one more. That's 9x by 2, 9 to the power x by 2 into 27 to the power x by 3. This is simple. Again, when we're doing indices, it should strike us 3 square x by 2 becomes very simple after that. Just need to have a good pair of eyes is what people say. As soon as you see 9 and 27, it should strike in your brain that 9 is 3 square. So we can get a power of 2 somewhere, and here we can get a power of 3 somewhere, which will settle itself. So this is 3 to the power x, and this is 3 to the power x. Because these gets cancelled out, so this is 3 to the power x plus x is 2x. That's your answer. Okay, one more if you like. We must remember, see, most of these questions we are doing is multiplication. Do not confuse, or we do not use a similar process when there are subtraction or addition, right? Because in those situations we are just not allowed to add, or we can't multiply them. Okay, so if you have something like 3 to the power x plus 3 to the power x minus 2 divided by 3 to the power x. Now you can't cancel 3 to the power x here or here. You have to take something common, right? You can write 3 to the power x. This is plus, remember, not multiply. So it's not as abstract. But these two are multiplied, minus 2, and then we do 3x. So continuing this, I like to complete it in this space because it's easier to look at. If I take this common, I have left with 1 plus 3 to the power minus 2, and then 3x. This 2 gets cancelled out. I'm left with 1 plus 1 by 9 is equal to 10 by 9. That's the answer. Very important, because we have plus and minus. We have to be very careful in the way we can cancel numbers out. Okay, so that's what we wanted to cover here. Here we complete indices. If you have any questions, please feel free to ask and put your comments and share this video. Thank you.